Welcome to Ridzi. Now we are continuing the session Straight Lines chapter module 2 here. In last session we have discussed about the module 2, the first part here, and the second part. In that the topic name is angle between the lines. The topic name is angle between the line. In that the question number 30 we are going to discuss here. So what is the question here? So if PQR are distinct is nothing but they are not equal. PQR all are distinct values here. Then he is given the equation PQ minus R of x plus R minus P of y plus P minus Q is equal to 0 and Q cube minus R cube into x plus q r cube minus p cube into y plus p cube minus r cube is equal to 0. Here it is in the form of, here he is given represent the same line if. So here he is given two straight lines. It is in the form of ax plus by plus c is equal to 0. Then represent the same line. He is saying represents the same line is nothing but the condition here, two lines a1x plus b1y plus c1 is equal to 0. This is one line. And a2x plus b2y plus c2 is equal to 0. This is one more line here. So if these two lines represent the same, then the condition will be a1 by a2 plus b1 by b2 is equal a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This is the condition here. So if you compare this equation with a1x plus b1y plus c1 is equal to 0 and also a2x plus b2y plus c2 is equal to 0 with this equation, then equation a1 will become q minus r divided by, what is the value here, q cube minus r cube. Similarly you can compare the second term r minus p divided by r cube minus p cube, and finally p minus q divided by p cube minus q cube. Here this is the condition here. If the two lines represent the same, if so it is in the form of a minus b, it is in the form of a minus b whole cube, sorry, a cube minus b cube, then a minus b into a square plus ab plus b square. This is the formula here. So this is the formula, a cube minus b cube is equal to a minus b into a square plus ab plus b square. Here let's expand in the form of a cube minus b cube, then it will become q minus r. So q square plus qr plus r square, and similarly you can write this one also, r minus p r minus p into r square plus rp plus p square, and similarly you can take like this, p minus q into p square plus pq plus q square. So let's cancel the terms here. So these terms will be cancelled. The remaining terms will be 1 by q square plus qr plus r square is equal to 1 by r square plus rp plus p square, 1 by p square plus pq plus q square. This is the rest of the term. So I am equating only these two terms. We can equate any two terms here. I am equating these two terms. What will be the answer? So it is 1 by a, 1 by, in the form of 1 by a is equal to 1 by b. So we can write a is equal to b also. So similarly you can write q square qr plus r square is equal to r square plus rp plus p square. So let's r square get cancelled here. So these two are equal. So let's bring p square here, p square minus q square minus p square. Let's send r minus p q minus r here, r minus p q minus r. Let's, it is in the form of a square minus b square, then formula is a plus b into a minus b. This is the formula here since. So according to that I am expanding this one. So q plus p and q minus p. If you take r minus r as common, q minus p here. If you take r as common, q minus p is the term here. Q minus p get cancelled here. Q plus p is equal to minus r. Let's bring r to left hand side. It will become p plus q plus r is equal to 0. This is the condition for this solution here. First of all, he is given p, q are distinct values. Ca is given, and he is given two straight lines a1x plus b1. This is two straight lines here. These are two straight lines, and he is saying represent the same line. Represent the same line is nothing but they are equal. So a1 by a2 plus a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This is the condition, and according to this condition, I am substituting the values of these straight lines here. After solving this one, we will get the solution of this condition p plus q plus r is equal to 0. And the next question is understand the question before solving the question. So, and the next question is question number 35. Area of the triangle formed by the angle bisector of triangle formed by angle bisector of coordinate axis and the line x is equal to 6 in square units. So, he is given this question. The topic is triangle and area of the triangle. Triangle and area of the triangle. So, this topic name is triangle and area of the triangle. He is given, the question is 35th question. Area of the triangle formed by the angle bisector of coordinate axis and the line x is equal to 6 here. So, let us take, I am assuming this is a line here. So, here to here the distance is 6. So, this will be 6 here, this will be 6 here. Angle bisector is nothing but here. So, this is A, B, C and the point is D here. So, this is the right angle triangle here. So, area of the triangle is ABC is equal 1/2 of base is BC into height is AD. So, let us substitute the values 1/2 into base is 12 and AD is nothing but 6 here. 2 1 ja, 2 6 ja. So, 36 units. The area of the triangle is 36 units here. So, this is a triangle here, this is a triangle. So, this is height, this is base. So, if you rotate like this, this will be the triangle. So, base is 12, height is 6. According to that, half into base into height. This is the area of the triangle. According to that, I am solving this one here. And the next question is question number quadrilaterals and area of the quadrilateral. Question topic name is quadrilaterals and area of the quadrilateral. So the question is the figure formed by the straight lines, the figure formed by the straight lines root 3x plus y, root 3x plus y is equal to 0, and the second equation root 3y plus x is equal to 0, and root 3x plus y is equal to 1, and root 3y plus x is equal to 1 is asking. The options are rectangle, square, rhombus and parallelogram. These are the options A, B, C, D here. So according to this question, we have to solve which figure is formed by using these four straight lines here. This is quadrilateral. Quadrilateral is nothing but it is having four straight line figure. It is a four straight line figure. So it may be all are four straight line figures here. He is given four straight lines here, and the topic name is quadrilateral. Quad is nothing but 4 and area of the quadrilateral. Topic name is quadrilateral and area of the quadrilateral, and he is given the question number is 38. The question number is 38 here. The solution for this one is, first of all, here he is given four options. All are four lines figures here: rectangle, square, rhombus, parallelogram here. So here we have four straight lines. I am taking root 3x plus y is equal to 0, and root 3x plus y is equal to 1. So I am taking these two lines together, and root 3y plus x is equal to 0, root 3y plus x is equal to 1. Here these two pairs of straight line, these two pair of straight lines here. These two lines are parallel. Why? Because a1 by a2 is equal to b1 by b2. Here a1 by a2 is equal to a1 by b1, a1 by a2 is equal b1 by b2, because these two lines are parallel. Again these two lines are parallel. These two lines are parallel and these two lines are parallel. So in all the cases, rectangle opposite sides are equal. Here also, everywhere the opposite sides are equal here. So parallel here, parallel, they are parallel. Next, the slope of these two lines, slope is nothing but y is equal. These two lines are equal. So y is equal to how much here? Minus root 3x. Y is equal minus root 3x. Then m is equal to how much? m1 is equal to minus root 3. m1 is equal to minus root 3. From these two straight lines, the slope is equal to how much? Slope m2 is equal to how much here? So root 3y is equal to minus x. Y is equal to minus 1 by root 3 x. So m2 is equal to how much? Minus 1 by root 3. Here these two lines are parallel, opposite sides. These two are opposite sides. These two lines are adjacent side. For example, if you take any quadrilateral here, so these two are parallel, opposite sides. So these two are adjacent. These two are opposite. These two are adjacent. The adjacent angle, the adjacent lines are not perpendicular. Why? Because so m1 into m2 is equal to minus 1. m1 into m2 is equal to minus 1 here. Here m1 into m2 will become 1. m1 into m2 become minus root 3 minus 1 by root 3. So root 3 can cancel, minus will become plus 1 here. m1 into m2 is equal to 1 here. So they are not perpendicular. They are not perpendicular. If they are not perpendicular, directly you can say rectangle and square is not possible here. Rectangle and square not possible. The adjacent sides are not perpendicular. If the adjacent sides are not perpendicular, rectangle and square is not possible. And here A1, A2, A3, A4 all are equal. So it is having all the sides are equal. It is having all the sides are A1, A2, A3, A4 and B1, B2, B3, B4. All are equal. 4 values of 4 lines are equal. So that's why the quadrature is containing all the sides are equal. All the sides are equal is nothing but, so it may be rhombus. So parallel should not come here. So the rhombus. The answer is rhombus. And in rhombus, the adjacent angle is not perpendicular. Adjacent angle is also not perpendicular. So the final answer for this one is rhombus. Why? Because it is having all sides are equal and adjacent slope are not perpendicular here. We are getting one here. That's why the answer is rhombus here. So this is all about the solution. And the next question is, the question number foot and image, question number 42. Topic name is foot and image. Question number is 42. The question is, the point on the line 3x minus 2y is equal to 1, and which is closer to the origin, which is closer to the origin. So first is given, the question is the topic from foot and image, foot of the perpendicular and image here. Foot and image, he is given the question number 42 is the point on the line, he is given one line, that is 3x minus 2y is equal to 1, which is closest to origin, So we have to, for example, it is origin and the point we have to find here, the point which is closest to origin, that is the perpendicular distance is nothing but closest to origin here. Here we have to find foot of the perpendicular. For example, somewhere it is origin and the line it is. So the point which is lies on this line to the origin to this line is called foot of the perpendicular, that is h comma k. So that's why we have to find h comma foot of the perpendicular, that is h minus x by a, this is the condition, k minus y by b is equal to minus of a1 x plus b1 y plus c by a square plus b square. So let's substitute the value. This is a b ax plus by plus c is equal to 0, where if you compare this equation, a is equal to 3, b is equal to minus 2, c is equal to minus 1. Let's substitute the values in this expression from the origin. Origin is nothing but O, that is x comma y is 0. So let's substitute h minus 0 by 3, k minus 0 by minus 2 minus of ax, a is nothing but 3 into 0 plus b into minus 2 into 0 plus c is equal to minus 1 divided by a square is 3 square and b square is minus 2 whole square. So ax plus by plus c is equal to 0, b is equal to how much here, minus 2, and c is equal to minus 1, and h by 3, h minus 0 is nothing but h by 3, k minus 0 is k by minus 2, and minus into minus, this will be 0 plus minus 1 here. So this by 9 plus 4, 9 plus 4. So this will be similarly h by 3 is equal to k by minus 2 is equal to minus into minus become 1 by 13 here. Then if you compare these two and these two once again, h by 3 is equal to 1 by 13, k by minus 2 is equal to 1 by 13. So then h is equal to, if you send this will be right hand side 3 by 13, k is equal to minus 2 by 13. So h comma k is equal to 3 by 13 and minus 2 by 13. The point it is foot of the perpendicular, that is 3 by 13, 3 by 13 and minus 2 by 13. Just substituting the values in this expression, this is nothing but foot of the perpendicular. Foot of the perpendicular condition here. H minus x by a, k minus y by b is equal to minus of ax plus by plus c by a square plus b square. This is the most important condition for foot of the perpendicular. If you substitute the a, b, c and x comma y values in this expression, we will get the foot of the perpendicular. The foot of the perpendicular is the point which is passing through the line, which is passing through the line 3x minus 2y is equal to 1. This is all about this solution. And the next question is, centroid, circumference, orthocenter, incenter. Centroid, circumcenter, orthocenter, etc. Orthocenter, incenter. This is topic name, and the question is, if one vertex of the equilateral triangle is the 46, if one vertex of the equilateral triangle is the origin and side opposite to it has equation, and side opposite to it has equation, that is equation is x plus y plus 1, x plus y plus 1 is equal to 0, and then the orthocenter of the triangle is, then the orthocenter of the triangle is here. And here the topic name is centroid, circumcenter, orthocenter, incenter. He is given the 46th question. If one vertex of the equilateral triangle, is the origin and the other opposite side of its triangle is the equation x plus y plus 1 is equal to 0, then the orthocenter of the triangle. Let us see the diagrammatical representation for this one. So this is the triangle I am taking. So one vertex of the equilateral triangle, this is equilateral triangle. So all sides are equal. It is having all sides are equal. This is origin 0, 0, and a line which is opposite to this point. A line which is opposite to this point, that is this straight line. The equation of this line, this opposite side line, that is x plus y plus 1 is equal to 0. This is the equation of a line opposite to this origin. Here this is the triangle OAB. This point is called D here. So here we have to find this point this point here, this is foot of the perpendicular, this is nothing but perpendicular. So foot of the perpendicular, foot of the perpendicular. Here when comes to orthocenter is nothing but here it is in the ratio of 2:1, 2:1, it is in the ratio of 2:1. So that's why if you want to find the equation h minus k, h minus x by a is equal to y minus k, k minus y, sorry, k minus y by b is equal to minus of ax plus by plus c is equal to 0. Here it is equal to 1 divided by a square plus b square. So h minus x, it is having origin x comma k is x comma y is equal to origin h comma k, we don't know, this is h comma k, this is h comma k here. So the line he is given x plus y is equal to 1 here. So let's substitute the value h minus 0 by a is nothing but 1, ax plus by plus c is equal to 0, where a is equal to 1, b is equal to 1, c is equal to minus 1. So let's substitute the value k minus 0 by b, b is equal to how much here, 1, and minus of a is nothing but 1, x is 0 and b is nothing but 1, y is 0, and minus c minus 1 by a square plus b square, 1 square plus 1 square. So h minus h by 1, k by 1. So h minus 0 is nothing but h, k minus 0 is nothing but k here, divided by 1, no need to write this one, so I am writing. So my 0 plus 0 minus minus 1, minus of minus 1, this is divided by 1 plus 1. So this implies h is equal to k is equal to minus into minus become 1 by 2. So then h comma k is equal to how much it is, 1 by 2, 1 by 2. It is, we are getting here, this is 1 by 2, 1 by 2, and it is in the ratio of 2:1, so it will become 1 by 3, 1 by 3. This is the answer for this one. This is the question here, and the next topic is so the question number 52, angular bisector. Topic name is angular bisector. Angular bisector. Question number 52, that is the acute angle between the lines. The acute angle between the lines. Acute angle between the lines, 3x minus 4y is equal to 3x minus 4y is equal to 5, minus 5 is equal to 0 here, minus 5 is equal to 0, and one more line is given 5x plus 12y, 5x plus 12y minus 6 is equal to 0, 5x plus 12y minus 26 is equal to 0, minus 26 is equal to 0. He is given is, first of all, here we have to find the condition for, is given acute angle. Here angular bisector, the topic name is angular bisector, but he is given acute angle between the lines. Here acute angle between the lines of these two lines, this is L1 is equal to 0, this is L1 is equal to 0, this is L2 is equal to 0. So it is in the form of a1x plus b1y plus c1 is equal to 0, and it is in the form of a2x plus b2y plus c2 is equal to 0. So first of all, we have to find the condition between a1 b1, a2 plus a2 b2 is equal to a2 b2. Now find here a1 from this one, a1 is equal to 3, b1 is equal to minus 4, c1 is equal to minus 5. A2 is equal to here, compare, if you compare this equation, A2 is equal to 5, B2 is equal to 12, C2 is equal to minus 26 here. So let's substitute the value A1 B1. So A1 B1 3 into minus 4 and plus A2 B2 5 into 12. So minus 12 plus 12 5 ja 60 minus 12 12 5 is 60. So it will be plus 48. Plus 48 is greater than 0. Then the condition for this one here, the greater than 0. Then the condition for this one is a1x plus b1y plus c1 divided by a1 square plus b1 square is equal a2x plus b2y plus c2 divided by square root of a2 square plus b2 square. Here if it is less than 0, here minus will appear, if it is greater than 0, here it is plus here. If it is greater than 0, it is plus here. If it is less than 0, it is minus here. This is the condition formula for this one here. Look, so let's substitute all the values here. This is the formula, and a1x 3x minus 4y minus 5 divided by a square is nothing but 3 square, b square is nothing but minus 4 square, and is equal to 8x. So 5x plus 12y minus 26 divided by, so a2 square is 5 square plus b2 square is nothing but here 12 square. And if you solve this one, I am erasing this one, I am erasing the condition here. So 3x minus 4y minus 5y, so 9 plus 16, square root of 9 plus 16 is equal 5x plus 12y minus 26 divided by 25 plus 144. 5 square is 25 and 12 square is 144. Let's add the values here. 3x minus 4y minus 5 divided by square root of 25 and 5x plus 12y minus 26 divided by 169. 25 plus 144, 169. Square root of 25 value 5. Square root of 169 value is 39. 13. 3x minus 4y by 5 is equal to 5x plus 12y minus 26 by 13. Let's do cross multiplication here. So 13 into 3x minus 4y minus 5 and 5 into 5x plus 12y minus 26. Let's multiply here. 39x, 13 4 ja how much here? 52. 13 4 ja here, 52 here. So 52 y, next 13 into 5 minus 65. Let's I multiply 13 3 ja 39, 13 4 ja is minus 52 here, and 13 5 ja 65. Next multiply 5 5 ja 25x, 12 5 ja 60y, and 26 5 ja 6 5 ja 30, 0 3 5 2 130. So 5 6 ja 30, 0 3 carry 5 2 ja 10, that is 10 plus 3 30, 130. So let's bring all the terms to this side. 39x minus 52y minus 65 minus 25x minus 60y plus 130 is equal to 0. And 39 minus 12 how much here? 14. So how much here? 14. 14x here, minus 52 minus 60 minus 112y. Next 65 plus 65 is equal to 0. So this is a complete solution for this one here. This is the straight line angular bisector of the line here. And the next topic is a ray of light along topic name is optimization and reflection in surface. Optimization and reflection in surface. optimization and reflection in surface. This is topic name. In this topic, the question number is 57. We are going to discuss 57. A ray is, the question is a ray of light, sorry, a ray of light along x plus root 3y is equal to root 3 gets reflected upon reaching x-axis the equation of reflector ray is he is asking. So first we have a topic name optimization of ray and optimization of reflection in surface here. So the question number is 57 here. A ray of light along equation he is given x plus root 3y is equal to 3 gets reflected upon x-axis, and the equation of reflected ray here. So for example, if ray is reflected on x-axis and it will be reflected like this. So this is the reflection here. So the equation, the slope of this one here, first of all, the slope of this one here, x plus root 3y is equal to root 3, and y is equal to how much here? Y is equal root 3, y is equal minus x plus root 3, and y is equal to how much? Minus 1 by root 3 x plus root 3 by root 3. So root 3 can cancel, y is equal to minus 1 by root 3 x plus 1 here. So if you compare this equation, y is equal to mx plus c, where m is equal to how much? Minus 1 by root 3. This is slope. This is slope of this one. This is the slope of this line is equal to this line. This is x-axis. This is x-axis. This is a line here. This line is x plus root 3 y is equal to 3, and we have to find this equation of straight line. This slope m is equal to this slope m is equal to m1 and m2. m1 and m2 both are equal. They are reflector rays. They both are equal here, x dash y dash here. This is origin here. This is the line here. The slope of m1 is equal to m2. This is a straight line equation, and this equation we have to find here. This straight line equation we have to find here, where slopes m1 and m2 are equal, and the point is here. The point, a line is intersecting x-axis. The point is root 3 comma 0. Root 3 comma, y value will become 0. Then the point will become here. It is at root 3 distance. It is at root 3 distance, and the y coordinate will be 0. Why? Because it is intersecting on x-axis. That's why the y coordinate will become 0. Here we have point and slope. Slope is how much here? m1 already we got 1 by minus 1 by root 3. After getting slope and point of intersection, we can find the equation of this straight lines here. So equation of straight line, equation of reflected ray here, reflected ray, score y minus y1 is equal to m into x minus x1, where x comma root 3 comma 0, x1 here, x1 y1 is root 3 comma 0, and slope m is equal to here. Let's substitute the value, say y minus 0, slope is equal to minus 1 by root 3, x minus root 3 here. So x minus root 3, if you multiply this term to this side, so y is equal to minus 1 by root 3 into x minus root 3 here. So if you multiply this minus root 3y, and if you multiply minus 1 to this total term, it will become root 3y is equal to minus 1 into x minus into minus become plus x root 3 here. Let's bring all the terms here. So x plus root 3y minus root 3 is equal 0. Otherwise we can write x plus root 3y is equal to root 3. This is the equation of reflected ray here, that is x plus root 3y is equal to root 3. This is the equation of reflected ray here. This is all about the topic of straight lines module 2 here. In this session we have discussed all the concept and all the questions of module 2. In next session we will discuss some more concepts here. Thank you one and all.